Okay, so as mentioned, my sum of roots, I made a careless mistake. It should have been 1 over 4. And these are my answers for part 1 and part 2. Okay? Now let's move on to part 3. For part 1, it is 1. For part 2, it is negative 55 over 28. Okay, you may watch the video again if you want to see the steps in detail. So now for part 3. Okay, so this is the answer for part 3. The sum of cubes will, in this case, be negative 83 over 64. Take note, whenever we have sum of cubes and difference of cubes, we will be using this form to get our answers. Because from here we can generate, we can rewrite the sum and difference of cubes into sum of roots and product of roots. Sometimes you require results that we obtained in the previous part over here. Yes? Alpha power 4 plus beta power 4 is actually rewritten as alpha square plus beta square, we square it, minus 2 alpha square beta square. Okay, that's what I have on the board up there. Alpha square plus beta square was found earlier on, that is negative 55 over 16. Alpha beta is 7 over 4. In worked example 2, they tell us that alpha and beta are the roots of the equation. 2x squared minus 5x equals to 1 with the roots alpha and beta. When you see this type of question, what do you need to do straight away? What did I always tell you to do?
Solve first.
No, you're not supposed to solve it. You're supposed to find alpha plus beta, alpha times beta. Okay? But before we do that, is the equation in the form ax squared plus bx plus c plus c equals to 0? Is it of this form? No, it is not. So I cannot simply use it as it is. So let me change it into the form in green color. So that is 2x squared minus 5x minus 1 equals to 0. Now it is of the form, and I can write down my sum of roots. Alpha plus beta equals to negative 5 over 2, which is 5 over 2. Alpha beta is negative half. Okay? This is standard steps, right? So next, I'm supposed to form equations whose roots are 3 alpha and 3 beta. You are supposed to come up with a new equation. Something x squared plus something x plus something equals to 0. And the roots are 3 alpha, 3 beta. Okay, how do we fill in the blanks over here? Okay, you can refer to page 46. So he is correct. Refer to page 46. We've got this box. We've got this box over there. It says that x squared minus sum of roots times x plus product of roots equals to 0. Okay? This is what I asked you to highlight yesterday also. Which means if you are given the roots, if you are given the sum of roots, if you are given the product of roots, you can write down the equation. Okay? Today, our roots are 3 alpha and 3 beta. These are known as our new roots. Okay? Because we've got so many roots. We've got alpha and beta. Over here, these are our original roots. So this is my original equation. And now I've got new roots. I need to form my new equation. You following so far?
Yes.
Okay, so in order to find the new equation, I require the sum of the new roots plus and over here product of new roots to get my new equation. Can? Is this okay? Or yeah,
Then what do you mean by old roots?
original roots. That was given in the question. You look, work example 2, alpha and beta are roots of the equation 2x squared minus 5x equals to 1. So that equation has roots. They are alpha and beta. They are our original roots. Okay? Now in part 1, they say find the new equation with the roots 3 alpha and 3 beta. 3 alpha and 3 beta, they are not alpha and beta. They are something new altogether. They are our new roots. So I need to find the corresponding new equation using this approach. Okay? This is not difficult. What is the sum of the new roots? Sum of new roots is 3 alpha plus 3 beta. Can we do this? It's simply 3 alpha plus beta, right?
Yes.
And do we know alpha plus beta?
Yes.
Yeah, we knew it from the original roots. So we said that, oh, alpha plus beta is actually 5 over 2. So this gives me 15 over 2. This is my sum of my new roots. What else do I require? Product. Product of new roots equals to
3 alpha and 3 beta.
3 alpha, 3 beta, which is 9 alpha, beta. Can I find that easily?
Yes.
Yeah, I've got my product of roots, right, which is negative half. So this gives me 9 times negative half, which is negative 9 over 2. Now with my sum of new roots, with my product of new roots, I can place them back into my equation. Over here, sum of new roots, product of new roots. And I found my equation already. Let me write it down on the side. So new equation is x squared. The coefficient of x squared is 1 because according to our textbook, page 46, which we have already derived, here the coefficient is going to be 1 because we divided throughout by 8. Okay, so x squared minus what? Sum of roots. Today our sum of new roots is 15 over 2. Copy down the x plus negative 9 over 2 equals to 0. This is my equation. So let me beautify it a little. X squared minus 15 over 2x minus 9 over 2 equals to 0. This is my equation. Okay? Do you like to have fractions in your equation?
No.
This is absolutely correct. No problem with this. But if you prefer not to have fractions, what would you do?
Times 2 throughout.
Okay, multiply by 2 throughout. So because this is an equation, I can do this. To get 2x squared minus 15x minus 9 equals to 0. I can multiply by 2 throughout because this is an equation. Okay, so this is also absolutely correct. Why do I emphasize that? Because some of you actually will do, when you're given something like x squared minus 15 over 2x minus 9 over 2 as the answer. For example, this is the answer. It is not an equation. It is an expression. For example, if this is your answer, you do something like this. Equals to 2x squared minus 15x minus 9. Are they the same? No, they are not the same. This is an expression. What you have just done is to multiply by 2 over here. How can they be equal? Okay, so know the difference between an expression and an equation when you can multiply throughout, when you can divide throughout. Any questions? No, okay, then let's move on. Next, part 2. Find, okay, I guess everything you can do it already. Let's try practice now 2 already. Okay, with an easy question. Practice now 2, question 1, part 1, and part 2. Let us take 5 minutes for this. We will stop at 8:37. Okay, so let me take you through the steps again. Write down the equation, write down the sum of roots, product of roots. Then find the new sum of roots. You find that it is 8 over 5. New product of roots, and substitute them in. That's it, as straightforward as that. It's just that the current example is quite simple. There are other more complex examples that we will go through also. Let's move on. We have finished part 1. And now for part 2. Find the equation whose roots are alpha over beta and beta over alpha. Okay, so again, we are going to use everything same. The template is all the same. Sum of roots now changes. Okay, product of roots also changes. And the only changes we'll make will be over here. Okay, so sum of the new roots, let me write it down really quickly. Alpha over beta plus beta over alpha. So we know that this is going to be alpha squared plus beta squared over alpha beta. Okay, then we already know how to find alpha squared plus beta squared in the previous examples. We also know what is the value of alpha beta. So this is not a problem. Then product of roots. This is the fun part. Product of the new roots. Alpha over beta times beta over alpha. How much is this? Yeah, it's simply 1. Okay, so my sum of new roots, whatever it is, goes inside here. And my product of my new roots is simply 1. So make the changes. Yes, you need to. You need to write those words so that you are able to follow your work when you do your checking. Okay? Now, I didn't show you every step over here, in particular the sum of new roots. If you were to try it out yourself, you will get, how much do you get? Practice now, 2, part 2, negative 74 over 45. Negative 74 over 45. So substitute them in to get the answer. Okay, so the final answer will be alpha over beta times beta over alpha. You cancel, you get 1. Right? So over here we have our answer to be x squared plus 74 over 45, x plus 1 equals to 0. Okay? And everything else is just a variation. So this is the approach to doing it, to solving this question. Okay? 2 things you have learned. Find all sorts of different combinations of the roots, whether it is alpha squared plus beta squared, alpha cube plus beta cube, 1 over alpha plus 1 over beta. Next thing you learn is to form new equations. And make sure you get the process correct. Okay, the roots of the equation, 3x squared minus 2kx plus k plus 4 equals to 0. Before we do anything, I want you to look at the screen. Look at this equation over here. Is it quadratic?
No.
Is it quadratic?
No.
Why not?
Got 2 unknowns. Yeah.
So what if there are 2 unknowns? What is the meaning of quadratic?
Highest power 2.
Is the highest power 2?
Yes.
Is the next highest power 1?
Yes.
Is the next highest power 0?
No. 8.
Yes, so this is quadratic. If it is quadratic, I can rewrite it to the form ax squared plus bx plus c equals to 0, correct? Are you able to identify what is a in this case?
Yes.
What is a?
3x squared.
No, what is a? 3. What is b?
Negative 2.
Negative 2k. Okay, this whole thing over here is simply b. Do we know the value of k?
No.
We don't know yet. Don't worry. What is the value of c?
K plus 4.
Yes, you must be able to do all this. Okay? Now, let's see what else they say. The roots are alpha and beta. Then they also tell us that alpha squared plus beta squared is 16 over 9. Information is that alpha squared plus beta squared equals to 16 over 9. What do you think we can do with these things? What do you think we can do with all the information we have so far? This is a sum and product of roots question. First thing you should do is alpha plus beta. Okay, alpha plus beta, sum of roots. Can we do that? What is alpha plus beta?
Negative b over a.
Okay, what is b now? Are you sure it's 2k?
2k, negative 2k.
Negative 2k divided by 3. Okay, so same thing again. I've got my sum of roots, which is 2k over 3. Next, product of roots, alpha, beta. What is product of roots? Okay, k plus 4 over 3. So, you see the steps are all the same. Here we give you 1 mark. Okay? Now, there is some more information that we haven't used yet. In particular this. What do you think we can do with it? Form an equation. What does the equation look like? 2k divided by 3 squared. How about we write out the general form first? Alpha square plus beta square must be equals to alpha plus beta square, then minus 2 alpha beta, right? So I just do the substitution. This gives me 16 over 9 equals to alpha plus beta, which is 2k over 3 square minus 2 times of k plus 4 over 3. Can follow? Anything fanciful over here? No, what are we left with? We've got an equation with an unknown, which is k. Can you solve for k?
Yes.
Yeah, sure you can. And that's what they ask you to do. Find the possible values of k. After we do this, we will end up with an equation. According to our textbook, you will see that you have 2k squared minus 3k minus 20 equals to 0. All the intermediate steps is just Emacs, which you have already practiced, you have done your homework. So when we arrive at this is another quadratic equation which you can solve using factorization, completing the square or quadratic formula. So in this case, we are able to factorize it to become 2k plus 5 multiplied by k minus 4 equals to 0. And we see that actually k is equals to negative 5 over 2 or 4. Do we need to reject anything? Is there any reason to reject anything based on the original equation? Did they say whether k must be positive or negative? They didn't. Okay, are we going to be dividing by 0 if I substitute in any of those values? Also no. So both answers are acceptable. Okay? How is this example? Is it difficult? Do you find it challenging? Okay. So we haven't done anything very different. The only thing is that we have seen how an equation with an unknown as a coefficient, with an unknown as the constant, these unknowns can be determined based on the clues given to us, which in this case is alpha squared plus beta squared. All we needed to do was to relate it to our sum and product of roots, which is what this topic is all about. Always start with that. Okay, so now we shall not do practice now 3 because it's quite straightforward. We go to practice now. We go to work example number 4. This is the last type of question that you will see for this topic. Work example number 4, the final type already. Given that alpha is the root of the equation, x squared equals to x minus 3. Root equals to alpha. Okay? When you see this, is it quadratic? Is this quadratic? Is the highest power 2?
Yes.
Yeah, okay. Do we have next highest power as 1? Yes. Do I have a constant?
Yes.
Yes. So, do you like it in this form?
No.
No. Change it to x squared minus x plus 3 equals to 0. Okay? Next, they tell us that the root is actually alpha. Which means if I substitute alpha inside here, it should work. Okay, that is what it means by the root is alpha. Okay, we can possibly have up to another root. Beta? Question mark. I don't know. Possibly another root. Okay, let's see what the question wants this time. Show. They want you to show that alpha cubed plus 2 alpha plus 3 equals to 0. How am I supposed to show this? I don't have any x anymore. Right? So earlier on I said that, hey, actually the root is alpha, right? Which means that I can substitute all this inside here and the equation will work. Okay? So let us do that for part 1.
So,
Yeah?
actually, I don't understand what is sabi.
You don't understand what is what?
What is sabi?
Okay. What do roots mean to you?
Solution.
Roots are solution. Okay? If I say that the root is, okay, let me try solving this first. X squared minus x plus 3 equals to 0. X equals to 1 plus minus square root 1 minus 4. Okay, there are no real roots for this, so I am unable to use this equation to explain what I mean by the solutions. Let me give you another example. Let's say x squared plus 3x plus 2 equals to 0. Okay? What are the roots over here? If I want to find the roots, it will be x plus 2, x plus 1 equals to 0, right? Then we have x equals to negative 1 or negative 2. Am I right?
Yes.
These are the roots, also known as the solution. Okay? So, if I didn't give you all these things, and then tell you, okay, roots are negative 1 and negative 2. What this means is that I can substitute this value inside here and the equation will work. For example, when x equals to negative 1, I've got negative 1 squared plus 3 times negative 1 plus 2. This is my left hand side, which is 1 minus 3 plus 2 equals to 0 equals to right hand side. Right? So when I substitute the roots into the original equation, the left hand side will be equal to the right hand side and it works. The equation works. When I substitute negative 2 inside the equation, it will again still work. You can find it out yourself. What if I choose to put in something that is not a root? For example, I put in 0. Let me try when x equals to 0. Which you should already know what we will get.
2.
When you put x equals to 0, left hand side equals to 0 squared plus 3 times 0 plus 2, which is 2, which is not equals to right hand side. Okay so far?
Yes.
So when x equals 0, the equation will not work. Okay, now back to our original question. Now they say that the root is alpha. Right? What this means is that if I don't know the value of alpha, I just know it's going to be a constant. When I substitute this back into the equation, left hand side will be equals to right hand side. But I don't like my equation looking like this. I prefer it looking like this. X squared minus x plus 3 equals to 0. Now I'm going to substitute them back inside and I'm sure left hand side will be equal to right hand side. Therefore, I can now write alpha squared minus alpha plus 3 equals to 0. Okay? Then I'm going to do manipulation. What happens if I keep it at the back of your mind? We want to show that alpha cubed plus 2 alpha plus 3 equals to 0. We're running short of time already. I want to show alpha cubed plus 2 alpha plus 3 equals to 0. Currently, what do I have? Are they the same? No. I require an alpha cube. Can you give me a suggestion of what I can do? What can I do? I want an alpha cube. I can multiply by alpha. Okay, if I multiply by alpha, what do I get? Alpha cubed minus alpha squared plus 3 alpha equals to 0. Am I getting closer to this?
Yes.
What do you think I should do next? I've got alpha cube already. What do I want to get rid of now?
Negative.
What do you want to get rid of? You want to get rid of this alpha square? You want to get rid of this 3 alpha? Any suggestions how we can do that? Do you know what alpha square is? You know what alpha square is? According to this, you see, we are going to be doing a lot of manipulation. According to this, alpha square is actually equals to alpha minus 3, right? What if I substitute that in? Substitute that inside here. Okay, what do I get? Alpha cubed minus alpha minus 3 plus 3 alpha equals to 0. Am I right? Okay, so alpha cube minus alpha plus 3 alpha equals to 0. Alpha cube plus 2 alpha plus 3 equals to 0. And shown. What do you mean re-explain the last step? You see, I've got my, this is my thought process. I've got my alpha square equals to alpha minus 3, right? If I substitute it in the original equation. And then I rearrange to get alpha square minus alpha plus 3 equals 0. Because I want alpha cube, that's what they want us to show. I multiply throughout by alpha to arrive at this. Now what they want me to show doesn't have an alpha square. So I want to get rid of the alpha square. Earlier on, I already had my alpha square. I'm going to substitute alpha square inside here, which is alpha minus 3 here. Expand it out, you will naturally get this. Watch the video again. Okay?